So we learned yesterday that in a distribution that's strongly skewed one way or the other, or has a very large or very small outlier, we'll find that the mean and median are not at all the same in their value. In our case here, where we were looking at these New York workers and the amount of time they spend commuting to work, we found that the mean was 31.25 minutes, but the median was only 22.5 minutes. That's quite a discrepancy. Part of the reason, a big part of the reason, is because of this guy right here who travels 85 minutes to work every day. He's considered an outlier on the upper end, and he affects the average. The average goes up considerably because of him being in our set of data. So the average, we said, is being pulled in the direction of that outlier or the direction of that long tail. And yesterday I said to you, write this down. I said, be sure to write down this phrase. It's mean to pull a dog's tail. The purpose of that phrase is to help us to remember that the mean is always pulled in the direction of the tail in a skewed distribution or a distribution with outliers. Therefore, when you are given a set of data to graph and asked to describe it, the measure of center that you would want to report in a skewed distribution would be the median, not the mean, because the median is a better descriptor of the middle of our data. Look at this set of data here. There was our median. It's sitting right in the center or very near the center of our data. And therefore, it describes that center much better than 31.25, which clearly is misleading. So, given that, when you compare the mean and the median, when a distribution is roughly symmetric, then you expect the mean and the median to be about the same. If it were exactly symmetric, which would be very rare and unusual, they would be exactly the same. But in a skewed distribution, the mean will usually be farther out in the long tail than the median. So the next learning target that we had is that we want to be able to calculate the quartiles in a set of data. And the quartiles basically divide a set of data into 4 quarters, each containing about 25%. So what you want to do when you're asked to determine the 5-number summary, which we'll be using to make our box plots, which was one of our other learning targets, what you do first is you have to put, I ran out of room. You have to put your data in ascending order, so smallest to largest. Q2 is called the median, so we already know how to find that median value. Q1 is the median of the observations that are located to the left of the median. Q3 is the median or middle of the observations that lie above the median. And then the interquartile range, which we'll learn or review, is the box and a box and whiskers plot, the middle 50% of the data. That's found by taking Q3 minus Q1. So looking at our data for travel times again, what I did was I took all of these 20 New Yorkers and the time that it takes them to get to work, and I put them in ascending order right here. There are 20 of them. So to find the median by hand, our calculator can do this as well, but we need to be able to do this with small sets of data without the use of our calculator. To find the median, or Q2, by hand, I can take the 20 pieces of data and I can divide by 2 to cut it in half, and in this case I'll get 10. So the median will be between the 10th and 11th position. Those are the 2 middle observations in our set of data. So the average of 20 and 25 is 22.5. Hence Q2, or the median, is 22.5. If I look at those observations that lie below the median, that would be these 10. The middle of those 10 would be the 5th and 6th. The average of 15 and 15 is 15, so there's your Q1. To find Q3, I look at just those observations that are above the median. There are 10 of them again. So when I divide 10 by 2, I get 5. So the median will be between the 5th and 6th position. So the average of 40 and 45 is 42.5. Now these two here, Q1 and Q3, are used to determine the interquartile range, which is the box in a box plot, which we'll make here in a moment. It's the middle 50% of the data. You take Q3 minus Q1, and it describes the spread of that middle 50% of the data. Now, not only do we use that Q3 minus Q1 to make the box in a box and whiskers plot, but it's also used to actually calculate the value of any outliers. So in the previous week, we were just eyeballing our graphs and identifying if we thought something was different enough to be an outlier. Now we're actually going to do some calculations. And I'm going to pause here and save what I have done so far to make sure I don't have a hiccup uploading it.